So I'm given this data, and I want to do quite a few things with it. The first thing I want to do is I figure out its correlation. So you remember that if the dots are typically trending downwards, we call that negative correlation, versus like if the dots were like going up, that would be considered positive correlation. So these dots tend to be going down, so I'll say negative correlation. And we don't really have a great way right now, a solid number of figuring out how strong the correlation is. So I could say that this is somewhere between weak and strong. I could see it argued either way. So now what I want to do with this is I want to find the line of best fit, and I want to find the equation of it. So what I'm going to do is I'm going to take this box that was lying around, and I'm going to make a line of best fit from it. And so it's going to go like, let's see, like this. Right? You just want to have, oh boy. It was a pretty all right line of best fit until I took a turn there for the worse, but whatever. So what I want to do is I want to come up with the equation for this line of best fit. So every time we write an equation, we're really just looking for two things. We're looking for the slope, and we're looking for the y-intercept. So one of those is a little bit easy to find in this case. See the y-intercept, see where it crosses right there? It crosses at 15. Okay. Now what I want to do is I want to find the slope. And to do this, I need to get 2 points. Now I don't want to find like the slope between like this point and this point, because neither of those points are on my line. In fact, I only have 1 point that's actually on my line of best fit. You know, the key thing here is I don't even need to use points that are previously given to me. Like this point goes through even, that's at 6, 3. And let's look for another point like that, like this one. This one goes through at 2, 11. Those aren't points given, but they're points on my line, so I'm going to use them. So to find the slope, I figure out, there's lots of different ways I can do it. If I'm given 2 points, I can do the old 3 minus 11 over 6 minus 2. So that'll be negative 8 over 4, which is a slope of negative 2. Should make sense. It looks like my line's going down, so awesome. So now what I want to do is I want to find, I want to figure some things out with this, this line of best fit. And this idea of a residual kind of pops up. So what I want to do is I want to find the residual for this point right here. We can see that it's off the line, but the question is, how far off the line is it? And how good of a job do we do predicting it? So residual is the actual minus the predicted. Okay, so when I actually plugged in a 5, right, like this data point, it's at 5, 2. It's an actual value of 2. Our predicted value is a little bit higher than that. It's all the way up here. This is my predicted, and this is my actual. Okay. And so in this case, I can see quite plainly that it's at 5, 5. So my predicted value for 5 is 5. And actually it was 2. So my residual is 2 minus negative 5, negative 3. That means it was undershot by 3, right? We can also find our predicted value by using our line of best fit and plugging in the x value. So if I plugged in x equals 5 here, I would get, to make a prediction for the height at 5, I would get y equals, that's negative 10 plus 15, y equals 5, and that would match my prediction. This time I use my graph to predict because the number was so clearly what it was, you know, but it doesn't have to be on our graph for us to make a prediction.